let us start. So, if you remember in the last class, we talked about, we started discussing HTTP 2.0, right? And we talked about the key features of HTTP 2.0, which includes binary framing. So, binary framing provides us better multiplexing, flow control, and concurrent processing without establishing multiple connections. Then it also provides multiplexing because we can send request and responses. Excuse me. We can send request and responses concurrently on the same connection, achieving multiplexing. Then we have header compression. Header compression reduces redundancy in header. It also reduces the overall size of the request or response as well. We'll see in a minute. Then we have server push, where server proactively pushes resources, and this will obviously lead to improve efficiency while loading a complex page. Right. So we started our discussion with binary framing, and in binary framing, we try to introduce binary framing by stating that we have a binary framing layer at the application sub layer at the application layer. uh, and traditionally, when we talk about HTTP 1.x, we used to have one complete text-based request or response, right? Which includes obviously the request line, headers line, and header lines, and the body as well, right? But in HTTP 2.0, we have divided this into different frames. We have headers frame, and then we have data frame. So all the headers will go into the headers frame, and the body, whatever we are posting, for example, on a link, right, or in a response, whatever is the data will go in this data frame, right? So then we said, okay, if we want to understand this in more detail, so we need to understand this in terms of streams and messages and frames. So where stream is a bidirectional flow of data, yeah. So where the stream is a bidirectional, you know, this is the stream, right? The stream is the bidirectional flow of the data, right? So we can send data back and forth to client and server, and then a stream contains different messages, right? And the messages contains different frames, okay, binary frames, and where a frame can, at least identify itself to which stream it belongs to, okay. So then we try to understand it from another, representation. So we said this is one stream, okay, and one stream have many different, or say one connection, rather I should say, one connection, right? And one connections have many streams. This is stream one, and then stream n, okay. And in stream one, we have many different messages. We have one, message two, message three. Similarly, in stream n, we have message one, message two, message three, and each message contains different frames. For example, frame one, frame two, frame three, and so on and so forth. Right. So today we'll talk about headers frame. We will look at the binary frame header. So if you have any questions till now,
No, sir.
no questions. Okay. So let's talk about headers frame. This headers frame, a binary frame has 9 byte header, right? And obviously, then we have the payload field, but we need to understand what are the details of these 9 bytes, right? Okay, so header is of size 9 bytes. Okay, means 72 bits. So let us try to understand uh, what is the usage of different uh, bits here. Okay, so here we have uh, a bit representation. Say from 0 to 7, this is 1 byte, and from 8 to 15, another byte, and then 16 to 24, another byte, and then 24 to 32 another byte, right? So in this way, we'll reach up to bit number 32, right? So so if I start from 0, the first 24 bits are used to represent the length of the frame. Okay, right?
Yes, sir.
And these 8 bits from 24 to 32 are used to represent the type of the frame. Since we have headers frame, data frame, right? So we need to define the different types of frames as well, right? So for that, um, we use this type field. Okay. So now, next time we'll start from 32, bit number 32, and first 8 bytes, starting from bit number 32 to bit number 40, we have 8 flags. Okay, so there are different flags here. For example, we have end stream flag. For example, we have end headers flag. Okay. For example, we have priority flag. For example, we have acknowledgement flag. Okay. There are other flags. For example, most importantly, we have push flag, means push promise. Okay. So these are the different types of flags that we can set using these 8 bits. Okay. Then and this will take us to bit number 40, and then 42 onwards we have uh, you know we have reserved 1 bit. We do not use it at the moment. Then we have 31 bits for stream identifier. Remember when we were defining frame, so we said the frame is the smallest unit, right, that carries data, request, response, and it can identify to which stream it belongs to. Yes, no? Or stream identifier के लिए we have how many number of bits? We have 31 bits. Okay, so this will complete our 9 bytes. Yes, no? Yes, right?
Yes, sir.
And this will also make the header of the binary frame, and then we have the frame payload. I mean, where we'll place the data. Okay, so again we can see that when we try to define binary frame, let's have a look at it, right? So we said the frame is the smallest unit that uh, contains frame header. Okay, and frame header can at least identify to which stream it belongs to. Okay, so we can see that having a look at the header, we have been able to identify, okay, how this can be done. Okay, so this is the first characteristic of HTTP 2.0, binary framing. So we try to have a look at binary framing, right? So and the next thing is multiplexing. So multiplexing is that we can send multiple requests and responses on the same connection. Concurrently. So we know that this can be done. But the third characteristic is important to go through, which is कौन बताएगा? Can you name the third characteristic? आप हैं?
Header compression.
या हेडर कंप्रेशन लुकमान ही सुन रहा है मेरा ख्याल है बाकी नहीं है क्लास में
Sir, yes, sir.
so why you're not answering me Okay, header compression. So let's talk about header compression. Okay, so वहाँ पे header compression में हमने कहा क्या कहा था कि what do we mean by header compression? वहाँ पे हमने कहा था कि it reduces what
It reduces the data in header, makes it more
and
efficient.
redundancy as well, right? Okay, so uh, let's see how we can achieve this. So header compression. In header compression, we use HPACK compression mechanism. First of all, this header compression in HTTP 2.0 makes use of HPACK compression mechanism. It uses compression mechanism. Okay, and it has two main components. Header compression has two main components. One is known as, the two components, main components are static uh, and dynamic tables, right? So header compression makes use of HPACK compression, making using two main components known as static and dynamic table. Okay, so, first, when we talk about static table, the static table contains the list of the common headers, right? Static, and I will give you an example as well. Static table contains the list of common headers. Okay. For example, common headers are uh, method, and method is get. Then common header, it can be get, post, delete. Okay, right? Head. Okay, these are the common headers, and at the moment I'm only talking about method. So this, if I go to the header lines, there are other common methods as well, such as host, content type, language, right, user agent, content length, etc., etc. Okay, so whereas if we talk about, देखते हैं इसकी detail. Whereas if we talk about dynamic table, dynamic table is built on the fly as the new headers are encountered. So these are the common headers that we are familiar with. Uh, these are That's why we call it a static table. These headers are always there, right? We'll be using any specific method out of these methods, or any specific you know header field out of the available header fields. So we'll see in a minute, right? So whereas if I talk about dynamic table, so dynamic table is built is built on the fly when as new headers are encountered. Okay, so as we encounter new headers, so uh, you know we have to construct or build the dynamic table, right? We have to build a dynamic table as well. This is not the only thing that we use in header compression. In header compression, uh, you know we also implement differential encoding, and differential encoding will help us to reduce redundancy. We'll see in a minute, right? So it will help us to reduce redundancy in the HTTP request headers. Okay, how? I leave it with a question mark. And it also implements Huffman coding. Huffman encoding. And Huffman encoding, what it does is basically it compresses the individual header values, right? We implement Huffman encoding to compress uh, individual header values. Okay, and by the way, encoding is a lossless compression, um, and in this technique, we replaces the frequently used characters with shorter codes, and rarely used characters with longer codes. Okay, so it's a lossless compression technique. That replaces frequently used or occurring characters with shorter codes and rarely occurring characters with larger codes. Okay, so let's talk about the first two components in header compression, the static table and dynamic table. So let's talk about first uh, the static table. Okay, so remember in static table we have um, common headers, and in order to explain this, let me draw a table here. A static table has at least four columns. Okay, so first we have index. Okay, then we have headers or header field name, header field name. Then we have header field value. Okay, and then we have Huffman code. Okay, so for example, the first index is one, and the header is authority. Okay, and then we have the value and corresponding Huffman code. For example, index 2 is a method, and the method is, say, get. Index 3 is also method. Method is post, right? Index 4 is, for example, uh, index 4 is a path, where I can give the path, for example. Index 5 is maybe again another commonly occurring path, right? We know this index.html. Okay, say six is maybe scheme. Scheme is HTTPS, for example. Okay, then we have say status. So status status is 200. अक्सर आपने देखा होगा when you send an HTTP request and if you receive the response in the form of text or something, right? So this means this represents what? This represents, excuse me, excuse me. Hello, hello. Right, all right. सर मैं ना लिंक करवा रहा हूँ कीबोर्ड के ऊपर वाली साइड का ना वहाँ पे स्टॉप मुझे समझ नहीं मेरी क्लास हो रही है या तो 11:20 में मुझे कॉल कर लेना मैं क्लास में हूँ। ठीक है ओके मैं तुमसे रब्ता करता हूँ हेलो सॉरी okay so then status is okay so if we send an HTTP request and we receive a response and response is displayed so the status is in fact um, 200 right. So we have these are the most commonly occurring headers. The list can be very long. For example, I can add content type, etc., etc., right? And then we have the Huffman code against this. For example, you know, uh, Huffman code is 001, 0010, and so on and so forth. Okay, clear? So, in a typical web-based request, I will send a message something similar to this. I mean, in HTTP 1.x, that is get, okay, and then, for example, the address that I want to refer to, okay, and then HTTP 1.1, yes, no, this is header line, or sorry, request line. Then we have header lines, for example, host, okay, and then in host we have www value www dot some say CUI Lahore dot edu dot pk. Then we have user agent. Okay, the value is Mozilla 5.0. Then we have content type. Okay, then we have the values, right? Then we have, for example, content length, right? Then we have value. Yes, no. So now if I have to send, for example, get in a request, how many number of bytes are required? Yes, I want to send this HTTP request. This is my typical HTTP request. I want to send this, right? First of all, I have to represent get. How many number of bytes I need to send? Let's assume that I need to send one for one character. I require 1 byte,
So that would be 3 bytes.
3 bytes. Okay. And what about this? If I have to represent user the content type or content length,
There would be n number of bytes
yeah,
depending upon the
and the total
character.
size of the request sometime exceeds is more than one 20 or 30 bytes, right? Bytes. I'm only talking about the request. But now, when I have to send this get message, right, or this method get, because this is the method field and the value is what get. For that, I have this index, you know, two. So what I do is instead of sending or representing get in binary, I will send 8 2. Okay, what I'll do is I'll send 8 2, where um, where 8 means in this 8 means that it's an indexed header field, and 2 is what? 2 means the index. Okay, so now आपको मेरी बात समझ आ रही है? So now instead of get, I will be sending
Yes.
8 2, where 8 represents what? 8 represents this is what? Boli Shabash. This is the
Index header field.
yeah, index, and its value can be from anywhere. ये जो index values हैं 8 to 8 8, the index value can be anywhere from 80 to 0 f, and these are by sorry 0 f. These are hexadecimal values, right? Hex values. Okay, this can go from 80 to 0 f. Okay, and 80 to 0 f represents what? It represents indexed header. आपको ये बात समझ आई? And now, for example, if I want to send content type, or I want to send content length, for example, or for example user agent. So user agent में देखिए कितने characters हैं. Okay, so I can write here, यहाँ पे I can have another index here. Okay, say 8 or user dash agent, right? And then I can have a value here, for example Mozilla. Now if I have to represent a user agent Mozilla, so what I'll write here, instead of sending this user agent, I will send 8 8. ये हमने खुद बनाया है, the value can be different in the actual static table. Okay, where this first 8 represents what? That it is an index header field, and the second 8 here represents the index, which at the moment is giving me what? Representing. So if you look at this, if you look at all the bytes that I need to represent user agent, and then the Mozilla slash 5.0, for example, right? So I just need to send these two hexadecimal values. And how many number of bits? In order to represent 8, I need these 4 bits. And in order to represent 0, I need these 4 bits. These 4 bits are representing 8, these 4 bits are representing 2. How many number of total bits are required?
8.
8.
8 bits.
How many number of total bits are required to represent, for example, this value? For example, this value. For example, this value. Or for that matter, component static.
Excuse me, sir.
Yes, and yes,
Sir, what time does the quest start?
11. Static and
Okay, sir.
dynamic tables, ये तो हमने पढ़ लिए. I'll share example, okay? I'll share an example. जाएगी ऐसी रिक्वेस्ट जैसे मैंने आपके सामने लिखी हुई है, okay? So ज़रा आपको समझ आ जाएगा उससे. So दूसरी चीज़ क्या थी वहाँ पे? Differential encoding, right? The second point was differential encoding. Yes, no? Yes. So differential encoding, what we do is we send the difference between the two requests only, right? For example, this is my request number 1. Say this is the first request. You get your पेपर्स एंड पेन रेडी, मैं बस क्विज 11 बजे स्टार्ट करेंगे. Request number one. This request number one has these fields. Okay, so we have first a method. Method is get. Then we have scheme. Scheme is HTTPS. Okay. Then we have host. Host is google.com, right? And then we have the specific path. Okay, so here I have the path. Then we have type. I mean the type of object, say it's image. Okay, then we have user agent, user dash agent, right? Let's say it's Mozilla 5.0, right? So this is my first, and obviously this request has representation in as we discussed in the static table, but just for the simplicity, मैंने सिर्फ request यहाँ पे लिखी. आपको बात समझ आ रही है? I have not represented this in a static table, right? So let's say this is my request, and this is my request number one, and this is my request number two. Okay, this is the second request that I want to make with the same server, web server, right? Where these values are same. Method is still the get. Scheme is still HTTPS. Okay. Host is host is still google.com. Okay, but maybe this time around I have a new path that I want to fetch images or video from or anything text from. Okay, and I have say this is also the same image. My browser is the same. What is the difference between the two requests?
Only the path.
Only the path. Now, the header fields, the uh, headers frame that we have talked about will only include this, right? What? The path. Okay? We will not send this get, we will not send this, HTTPS, right? We will only send the difference between the two requests, right? Similarly, if I want to make another request, this is my request number three, I will only send the difference between the request number three and the request number two in this case. This will further reduce the amount of size, even if we are representing, even if we have, for example, for this we have 8.2, for this we have 8.4, for this we have 8.5, 8.6. Even we if we have to send 1 byte, we are even saving this 1 byte, you know, also. Yes, no?